Properties of natural resources. Properties of air. Air is colorless. Air cannot be seen, it has no color because all its constituent gases, oxygen, nitrogen, carbon dioxide and water vapor are colorless. Yet, we feel the presence of air. When we inhale and exhale, we can feel the air. Air occupies space. When we blow balloon, its size increases. This shows that air occupies space. Air is a mixture of gases, so it does not have any shape of its own. However, it has mass and weight. The molecule of the gases in the air are in constant motion. When these molecules strike a body, they create pressure on that body. This is the pressure of air that we call atmospheric pressure. The piston can be pulled out easily. The piston then remains in that position even if you let it go. Now, close the inlet hole of the syringe tightly with your thumb. Pull the piston and let it go. The force required to pull out the piston is more than before. When the pulled out piston is released, it is immediately pushed in. On pulling the piston with the inlet hole of the syringe closed, more space becomes available to the air in the syringe and it becomes rarefied. As a result, the pressure of the air in the syringe is lowered. Comparatively, the pressure of the outside air is very high. That's why when the pulled out piston is released, it is immediately pushed in. If this experiment is repeated, holding the syringe in different positions like vertical, horizontal or inclined, the piston is found to go into the same extent in all the cases. From this, we can infer that atmospheric pressure is the same in all the directions. Atmospheric pressure on the moon is negligible as compared to Earth. It's an infinitesimal amount of air when compared to Earth's atmosphere. At sea level on Earth, we breathe in an atmosphere where each cubic centimeter contains 10 is to the power 19 molecules. By comparison, the lunar atmosphere has less than 10 is to the power 6 molecules in the same volume. Under ordinary conditions, atmospheric pressure at sea level is about 1,01,400 newtons per square meter. It can be measured with the help of a barometer. As we go higher above sea level, atmospheric pressure decreases. Take another example. On blowing through the straw, the air at its open end is pushed away and hence the pressure of the air at the opening goes down. As the pressure of the air near the upper end of the erect straw becomes less than atmospheric pressure, the water in the cup is pushed from where the pressure is higher to where it is lower, that is, in the upward direction, and the water comes out in the form of a fountain. The more forcefully you blow, the higher will be the fountain. This straw fountain works on Bernoulli's principle. In 1726, the Swedish scientist Daniel Bernoulli put forth the important principle that the pressure of air decreases when its velocity increases, while the pressure of air increases when its velocity decreases. If a body is moving through air, the air pressure decreases perpendicular to the direction of the motion, and the air in its surroundings flows rapidly from higher pressure to the lower pressure. When there exists a difference in the air pressure at two different places, the air starts flowing from the place of higher pressure to the place of lower pressure. At such times, we feel a breeze or a wind blowing. Thus, winds are an effect of the difference in air pressure.